So show me your work, show me your steps. If you have highlighters, I'm not going to give you bonus marks, but it sure helps. Uh, so what we're going to do now is continue with composite shapes, but now we're taking away. It's like there might be holes in the shape, or there might be a chunk missing. We call that truncated. When something is cut, it's truncated. And so I want to do this, but then I also want to start, uh, which is probably not going to happen today, but tomorrow I want to start talking renovations, projects, how much does it cost to paint a room, to do different things. So today is kind of like the last day. We're just focusing on shapes themselves, and then we're going to move on to the next. Okay. So we have, I don't know if you see this, but if we're trying to find a surface area, I'm going to use most of the space for surface area. So I'm not going to do this here. I'm going to use surface area here. Okay. So how would I do? I'm supposed to find just this chunk right here. And what I will do is I will split this into two shapes. I have the larger cone on the outside. And always read carefully, because if it doesn't say anything, we're assuming that this is closed, right? This is closed and this is closed too. So unless I tell you it's a cup, the top is open, then this will vary. So I want you to start thinking big picture. So I have the big one, and what else do I have? I have a small cone here. Do you see that? A small cone there. So what I'm going to do here is I'm going to go surface area of the large cone minus, I'm going to call this lateral surface area of the small cone. Why not the whole thing, Mr. Dirksen? Because I want this to be left behind with that shape, right? Because this is really what I'm trying to find. So I'm going to take the whole cone, the large one, subtract just the LSA of the small cone. And what do I need to do yet? Because right now, if you do this, yeah, I need to add another circle. You see that? I need to add this circle here. Plus small circle. And this is where I'm going to go like that. I'm going to go like that. I should have done a survey beginning of the class, beginning of the semester, how many of you will use highlighters? And then at the end of the class, how many of you are using highlighters? See if there's an uptick there. All right, so this is my order. This is how I'm going to do it. I choose to do it this way. I know there's a lot of folks in here that will go various ways. So I know that there's going to be circles here, so I'm going to call this capital R. I'm going to figure that out, and I'm going to actually use all decimals. If I divide that by 2, I get this in inches. Lowercase r is 0.5 inches. I got that. I'm going to call this capital S. That's the big slant. And there's a small slant here. Some students will be like, this is my small slant. Obviously. No. This is not the cone, right? We're talking about this cone right here. So lowercase s. And so what are we going to do to find lowercase s? Yeah, subtract these two here. Okay. So I'm going to, just on the side here, 7.85 minus 4.32. And that is 3.53 inches. Sorry, it doesn't quite line up, but it is. Okay, So you've got that. So capital, lowercase capital, just to differentiate between the two. And now let's start, okay? So we have surface area of the large cone. That would be pi r squared plus pi rs minus pi rs plus pi r squared. Does that make sense? I always bust my brain. How can I make this easy? But you can't really make it that easy. You just have to try it yourself. Okay. And now let's plug in pi capital R squared plus pi capital R S, which is 7.85, minus pi R, which is that lowercase r, S plus pi R squared. There. So now the grand finale. I'm just going to tell you what that is because I'm looking at my time and it's not looking good. I could have canceled something out, couldn't I? No, right? We're good? I'm just double checking before I run, okay? Before I reach the finish line. So this is the large cone here. I subtract the that. Because if I only subtract the lateral surface area here, I'm leaving sorry guys, I'm only subtracting this part. If I subtracted the whole thing, yeah, we're good. We're good. I just felt like something was missing here, but we're good. This is 5.5449, as you can tell. Pi times 0.5 squared is 0.785 ... And those of you who had me before, be warned, I may tomorrow come back and it's like, actually, make corrections to page 15, but we're good, we're good. Which means that it's plus, final answer is 43.62 squared inches. Okay. Now total volume is volume of large minus volume of small. Right? That's all it takes for volume here. The only problem is, what does volume require? What's that? Height. Yeah, I need my height. Okay. So I'm going to do this on the side here. If I take the large one, I have 7.85 here. I have 1.625, and I need to find capital height, right? capital H. When you're missing a leg, what are you going to do? You take the hypotenuse, square it, and you subtract, in this case, the radius, the other leg. It's leg hypotenuse minus leg to get that. So that gives you 7.679. Nope, no root there, guys. It's already rooted, and you're about to boot it. Yes. Here, 7 points, and that is in inches. Okay. Then the next one, so this is capital H, the height that is from the whole entire shape going through there. For the smaller one, I'm going to call that lowercase h. That is 0.5 here, right, the radius, and this is 3.53. So same thing. You take the hypotenuse, square it, you subtract the other leg, square it. Lowercase h is 3.494 ... I'm going to underline these because they're important to me. But this is an aside, right? Will all the examples on a test be like this long? Probably not. It's going to be either surface area or volume, right? So, but in the notes, right, I give you the full picture. So total volume is pi r squared times capital H divided by 3 minus pi r squared lowercase h divided by 3. So that's 1.625 squared, 7.6799 dot over 3, and I'm in trouble here, minus pi 0.5 squared times 3.494 dot over 3. Let me zoom into that. Sorry. This is a bit crazy here. And I will tell you that it is 63.711 dot minus 2.7445 dot. So total volume is 60.97 cubic inches. All right. The homework will actually come straight from this booklet. Like so, it's straight from here. I'll ask you to do, once you're done writing this down, I'll write it right on this page next to this whole thing. Mr. Dixon, next time, may I suggest using the space next to the shape to do the volume? Yes, I will. Okay, so this is a little messy, okay? Because I just can't do every example that you will ever encounter. So homework. There's one question on page 24, I believe. Hold on. Page 24, yeah. Do that truncated cone at the bottom there. So just question 2. And then page 19 to 21. You're like, what? I'm going to give you the tougher ones. The tougher ones to try. So that would be question 1, question 4, question 5, and 7. You're not going to like 7, but try it. And I actually, in Tinkercad, I actually put those together. So tomorrow I'll show you what it looks like. Maybe I can post it on Google Classroom, and I think you need an account to see them. So I don't know if you have a Tinkercad account. Maybe just leave it for now. It could be, right? I use my personal account to make it.
I use it for electronics. That's why.
Oh yeah, they have the circuit boards, right?